It's Alan Edelman, and this little snippet will be about array basics. So if you want to define a vector, you can just go v equals 1, 2, 3, 4 with commas, and you can see that the size of v is 4. However, if you want an array, one way to do it, here's 1, 2, 3, 4, 5, 6, with a square bracket over here and over here, and the size of w is 2, 3. So just to show off a few quick things you could do, if you want the upper left element, w of 1, 1 is 1. If you want the lower right element, it's the second and third row, you get 6. If you want the entire first row, you can go comma colon, which basically says take the entire first row, and it'll come back as a vector. Or you could take the entire first column, which also comes back as a vector. A vector is one-dimensional. It's not like it's an n by 1 or 1 by n. It's just a one-dimensional object in Julia. You could also slice through some planes, so you could take 2 colon 3, and you'll get a 2 by 2 array that comes out. So now let's define a few arrays. Here's a random matrix with the elements chosen uniformly from 1 through 9. It's a 3 by 4 matrix. So if I execute this a few times, you see I get different matrices. But either way, the size of A1 is always 3 by 4. Okay, here's some random pretty characters of various kinds, or interesting looking characters. So if I didn't have this pretty print, which appears just below me, you'll see it's kind of an ugly print. It's not terrible, but it has those quotations. And so the pretty print just kind of makes it look nice, and it looks just like this. So what we do is we're actually converting every character to a string and then just making it really look pretty. I don't read this. This was some magic that your TA Shashi once wrote, which makes it look nice, but I'm not going to worry about that. Here's some colors, distinguishable colors of 100. We can go a little slower. We could take distinguishable colors of 3. You'll see we have 3 distinguishable colors, or 6. So the idea is that there are colors in this world that are quite contrasting to the human eye, to the normal human eye. And so these distinguishable colors, like when you make a graph or something, you're supposed to have very different looking colors. So here's a bunch of distinguishable colors, and here's just some random 10 by 10 array of these colors. So every time I do this, I get a different random 10 by 10 set of colors. All right, here I just downloaded the Corgi, just took it off of a web page, and here I downloaded a Snoopy. And so here you see I could have a random 5 by 5 array consisting of Corgis and Snoopies. And so every time I run this, it takes a little bit of time, but you'll see I get a different 5 by 5 array of Corgis and Snoopies each and every time. Okay, or here, a little bit of code that's going to, I can copy the first matrix, which is a bunch of numbers, and then put a 1, 2, 3 in the upper left element. Or similarly, I can take a 5 by 5 array of Snoopies and put a Corgi in the upper left element. Here's a multiplication table. This is what's called a comprehension in programming languages like Julia. So it kind of looks like math set notation, where you have I times j for I equals 1 to 5 and j equals 1 through 5. This is a comprehension. You could do it with a double for loop like this one, but it's a little bit clunkier. People tend to prefer comprehensions when it can be done. Or you can even do it like in other programming languages where you really have just the nested loops. But again, the comprehension is much, much nicer. So people tend to like that. If you just square an array, you get the matrix multiply, the matrix times itself. However, if you do point square, you get the element-wise square. Okay. You can also concatenate matrices by just putting them next to each other in square brackets. And so here's A4, which is double the number of columns that A4 had. And you can also vertically concatenate with semicolon. And so you get A3 semicolon A3 gives you exactly that. Right? You could kind of combine these and horizontally concatenate and vertically concatenate. Okay, that's it for basic arrays. Thank you.